Hi, and welcome to the Low Level Devil channel's Raspberry Pi Pico series. I've gotten a lot of requests recently to show how to debug your code on the Pico. So in this video, that's what we're going to cover. So let's get started. First, there's a different repo you need to use. I'm going to put this in the description. So if you use this Pico debug repo by this guy here, he has a file that you can download. See, Pico debug gimme cache.uf2. You'll want to save that file and put it on your Pico. So let me find it here. So it downloaded to my downloads folder. Just drag it onto your Raspberry Pi, and that's going to cause the Raspberry Pi to reboot. So now if I go in and type dmessage, you should see it added this new device. Here we go. Yeah, right here, CMSIS-DAP. So that's the new device that it created. So that's going to be this debugger device that it's putting on there so that you can run ELF files on it and debug them using only one Pico. So you don't have to use more than one Pico. So if you go to this how-to section, you start with the building.md. You want to download this specific SDK, not the official one, but you want to download this branch of it because it has some changes in it that will allow you to debug. So you can just clone this repository. I'm going to put it in my /opt directory. You can put it wherever you want, really. So next we'll go into that directory, and then there's also a submodule update we want to call --init, and that'll take a little while to run. That's going to update the tiny USB package so we can run the USB debugger utilities. So now that we have that, we also want to get the examples here because we're going to use that to show how to debug. I'm just going to take one of their examples, and this is from the official repository. There's nothing special about this one. Now there's several different packages that you want to install as well. First you'll want to call sudo apt update. Also, I wanted to mention I'm doing this on Ubuntu 20 point something, whatever the latest stable is. I don't typically use Ubuntu, but I know a lot of people out there do use it, so I'm going to show how to set it up on this to make it easier. So you want to pretty much just copy and paste all these different packages that you want to install. So I'm going to let that run for a little while. Okay, so now that it's finished, let's just go into that directory. I'm going to show you how to build the samples. There's another video that covers this too, but I wanted to start this one from scratch since it's a separate package that you actually have to download. So in the Pico examples build, first we want to set up our Pico SDK path. And actually, let's put this in our bash RC file. That way we don't have to do this every time. I'm just going to skip down to the end here. Oops, I messed it up. Try that again. Alright. So at the end, you just want to put export Pico SDK path equals whatever path you downloaded it to. Mine, it was opt Pico SDK. Then source it to refresh that. Alright. So now we should be able to run the make command. Okay, so you'll want to type cmake-d cmake_build_type equals debug. Then also the cmake_c flags equals, and then with quotes -g-o0, because we want no optimizations so you can step through all of your code. And also for the cxx flags, actually it's flags debug flags. So let me change that, flags_debug. And let me move this over so you can see it all. So Same for the CXX flags debug -G -O0 and then dot dot. So now hit enter, and that's going to configure. So all the build files have been written. So now we want to go into the specific package. Let's see, I think they're using Blinky. Yeah, Pico board, Blinky. So we'll use that as an example. Just want to make sure this builds, because if it doesn't build, then there's something else wrong. Alright, all the files look right. We should be able to just make, and that'll just take a couple seconds. Okay, yeah, it looks good. So we have the Pico board blinky.elf. That's the file we're eventually going to debug. Now before we can debug, there's a couple other things that we need to do. So let's go back here under OpenOCD.md. We need to follow the instructions in here to get his version of OpenOCD as well. But first we need to install all these packages to build that. So we'll just copy and paste those. And again, I'll put these links in the comments, in the description, so that you can run them yourselves. Okay, so yeah, first we need to install all of these packages, and then we're going to need to clone his version of the OpenOCD. You see it's in that same user's GitHub. So we're going to git clone there. I'm going to put it in my opt folder. So I'm just going to paste that in there. It should only take a few seconds to clone that, depending on, of course, your speed of your internet. So once that finishes downloading it and receiving all the objects, then we're going to go into the folder for OpenOCD and run the build process. Okay, and there we go. So OpenOCD, we want to run /bootstrap. That's going to create the configure script. So now we can run .configure, and you need this special flags here that enable CMSIS DB. So you just copy and paste it from there as well. And once this this configure completes, then you can run make. It says -J4, but depending on how many cores you have, you can put J8. Or if you have a 12-core computer, you can really put -J12 if you really want to, and use all 12 of your cores. But I'll let you decide on that, and you don't need to do the -J option at all either. That's just to help it run faster by making use of a multi-core machine. So I'll let that run. And now that it's done, next we need to install this GDB multi-arch. So if you just copy that, and if you don't use an Ubuntu or a Debian-based distribution, you might have different commands. You just kind of have to Google for which packages offer these same abilities. So that should only take a minute to, yeah, just a few seconds to install. So now we should be able to run this OpenOCD command. Now I'm going to run this in a separate window. Let me see, detach terminal. Alright, so I'll paste it in here. Now you can see right away we got an error, unable to open CMSIS-DAP. That's a permissions issue, but there's a way for us to get around that. So what we need to do is create this file as a pseudo user. So etc udev rules.d/98-openocd.rules. Looks like Vim isn't installed on this. I'm just going to install Vim real quick. Should only take a second. I don't like using the vanilla VI. Alright. So once Vim is installed, we're just going to rerun that same command. We need to create this file so that we can set up the rules so that a user has access to call this. So I'm just going to paste this in. It's basically an action on add change. Let's see, subsystem, USB, TTY, hydra. Alright, so essentially the attributes CMSIS-DAP want to set mode 664 for the group plug dev. So we need to create this group and make sure our user is in it. So to do that, you'll just do group add plug dev. Looks like it already exists for me. I must have created it for some other purpose earlier. So yeah, so my user probably has already added to it too. If I type groups, yeah, plug dev, I'm already added. So if you want to add it, I'll show you quickly. So you just need to type G password, and then let's see, it's -A is for add, the username, and then the group name, plug dev, and permission denied. Yeah, you need to sudo use that. Yeah, I've already added it, but it looks like it doesn't complain about that. So you might need to add that for your user. And now you're supposed to be able to run this command, udevadmin control -- reload, and that's supposed to work, but doesn't always work for me. So if I try running that command again, we'll see. Yeah, this command. Yeah, I still get that error. So what I'm going to do is just reboot. So I'll go ahead and reboot and then continue when I restarted. Alright, so now that I'm restarted, I'm again going to copy this command, paste it in one of the windows. And now it's working. So listening on port 3333. So now I should be able to debug this. Let's go to the Pico examples. Again, to build Pico board Blinky. Okay, yep. So I should be able to run GDB. So let me expand this window a little bit. So if we run GDB multi-arch and then the name of that elf file, blinky.elf, yep. So now we have our GDB console. So first we'll want to type target remote localhost the port 3333, and now we'll type load. You can see something's happening. It's loading the executable. Now monitor reset init and continue. So now at this point you should see the blinking happening on your Pico, showing that it's running. Yeah, there's another way we can stop this. So let me just Control C. I'm gonna just quit this. Alright, so I'll run that again. Oh, first, before we load, we gotta do that remote. Target remote localhost :3333 load, and this time we'll do monitor reset init B main to put a breakpoint on main and continue. So now it's stopped at the breakpoint on main. So now we know we can run GDB manually through the console, which is nice. So we know that we can debug it, but nobody wants to actually run GDB in a console. It's a pain in the neck. So let's work next on getting Visual Studio Code working with this. Alright, so I'm going to open up Visual Studio Code. Okay, now we need to go add some extensions. So the first one, there's actually listed in here too. So if you go back to the how-to section, let's let that load. We want the vscode1.md file. So there's two VS codes. This is the one we want, vscode.1. Okay, so these are the three tools that you want: the C++ extension pack by Microsoft and the Cortex debug. Actually, you don't need the CMake one. I think that's by default installed in the extension pack. So let's search for C++ extension pack. And you want to make sure it's by Microsoft. That's the right one to install. So go ahead and click install. That'll take a little while. Also, while that's installing, I'm going to open the folder, file open folder. Going to go to the examples, which I put in opt. So I'm going to open the source code for that Blinky example. So we want to go to Pico board, Blinky. Yeah, so that should be it. So that's got blinky.c in it. So just click OK. Just want to make sure we got this all in here. You can close these pop-ups. And yep, all the code in here. All the code in here for it. So you can again close all these pop-ups that are popping up. Let's check on the status of the extension pack. Install. Okay, looks like it's installed now. So let's do the Cortex-debug. I'm going to go click install on that one too. That one only take a second. Okay. So now that we have those installed, let's go into the code here. We can break up on a new terminal, and we want to go into our build directory. So down in Pico examples build, Pico board, Blinky. We can run make. I think we already ran it before. So let me expand this here. Okay, so I'm just going to add a little code here at the top. Int counter equals 0. We'll do a counter plus plus, counter plus plus, counter plus plus, and I'm going to add a breakpoint. Alright, so now what I want to do is run make again, so it updates with my latest code. Now I want to run start debugging. You want to select C++ GDB and then the ARM none EABI GCC. So it's the second one for me. So now if you select this, that's going to, it might have some warnings here. You can just say debug anyway. And open the launch.json. Okay, what did it prompt me for this? Let's click that again. Alright, so there's our launch.json. So I'm going to just paste in a correct one. We don't want to use this one. We want to paste in, let's see. Okay, and now here we have our new one. It has name, I just call it debug Pico, device RP2040, GDB path, we want to use GDB multi-arch, same we did by the command line. For the executable, this is where the ELF file we want to test, so I'm just going to use the path for the one that we were using. Let's see, just type pwd. I'll copy this, paste it in place there, and then we want the ELF file. Should be pico board underscore blinky.elf. So CWD, we're just using the workspace root, and the type is Cortex debug. That's the extension that we installed. Request launch, server type OpenOCD, and then config files. These are using some of these configs for the RP2040 and OpenOCD launch commands, transport select, and adapter speed 4000. And now the SVD file, we want to use this Pico SDK path. These hardware regs rp2040.svd. When run to main is true, and our post restart commands are break main and continue. So now that we have this, let's save it, and we should be able to just go to run, see. First we need to make sure that OpenOCD that we had started before is stopped, because Visual Studio is going to start it automatically. So just Control C to kill that, because that's right there, it's going to start it for us. So now run start debugging and give it a few seconds here. Alright, and there we are. We got a breakpoint in main on our counter variable. So let's step past it. So now counter should be 0. We run past 1 counter plus plus. Now counter is 1. Counter is 2. And this is all running on that Pico. So there you have it for the C++ side. Let's actually add an assembly file, because we can actually see, now that we have the Cortex debug in there, we can also show the registers. So let me add another file. I'm going to call it test.s. Okay, so test.s, and I want to add it in the add executable section of our CMake lists. So let's do .global asm test, and then asm test for the label. Okay, there we go, asm test colon. Now we can write our instructions. Let's move the value 1 into R1. We'll say move the value 2 into R2. Let's do a add here. Gonna add R1 and R2, put it in R3. Let's say move R4, R3. You can do pretty much anything you want here. I'm just adding some of these things so we can step through them and see the registers update. Let's use a shift here. So I want to put the value 1 in R6, and I'll use LSL, logical shift left. So I'm going to shift R6 1 to the left several times, so we can just see it doubling each time, and then BXLRT and our function. So I'm just going to take that and declare it above my main void asm test, and I'll just call it before our counters update. So now I need to build it again. Just call make. You can see that's rerunning our configure and all that. And yep, it's got the test.s in there. So we should be good to go. Let's just start debugging again. Let's let it run. And it stopped on our breakpoint, so let's step 1 ahead. And now we want to let's step into this asm test function. Step into. So let's find our debug. There we go. Now we take this Cortex registers, we can actually drag this up so we can see it a little better. You can see it's got the values in all the registers currently, so if I step past that first line, now R1 has the value 1, now R2 has the value 2, now R3 has the value 3, move that to 4, and 5 has 170. Now 6 is 1, now if I shift over it's 2, 4, 8, 16, 32, 64, 128, and now we shift out of there. So now we're back to the counter, and counter value is 1. And we can keep stepping through all the code in here. So that's it. I think that's a good start off to show you how to debug your C++ code on the Raspberry Pi Pico. I know they have an official way to do it, but it requires using 2 Picos. But this repository that this person created makes it down to only 1, so it's pretty nice. So if you have any questions about this, go ahead and ask them in the comments. Also join our Reddit subreddit. If you have any more extensive questions, then we can answer them in there. And again, if you like this video and learned something from it, please like and subscribe. And thanks again for watching.